Hello, Mr. Chandler. This is me and Nathan's part of the project. We're doing molecule xylene, right? So, to start, xylene has a chemical formula of C8H12. It is a nonpolar molecule. We know this because it cannot dissolve in the nonpolar molecule, water. And on top of this, the molecule shown right here, symmetric and has an even distribution of charge. The molar mass of our molecule is 106.16. We can tell this because the math listed right here. Moving on, we have a concentration calculation right here to figure out our molarity. To start, we have 0.01 ppm of xylene parts per million. This so we would convert that using the H2O, so on and so forth to get our molarity, because molarity ends up being moles over liters, which is what we convert to. And the reason we use 0.01 is because we didn't have a highest level detected, so given 0.01 is what we had. Moving on once again, here's our solubility. So there's no solubility for xylene. There's no actual KSP value, but well, there is. It's our concentration right here. Our molar concentration is also a solubility because there's nothing you can really do with the rice chart for the most part. So as you can see right here, to kind of display the solubility and how it works, xylene always sits on top or below water. It never combines with it, and if it does, it's in minuscule amounts. It just won't because it's non-soluble. And the last thing for me is molecules calculation. We have 20,000 gallons of water in a water tower, right? So we convert from gallons to liters, and then using our concentration calculation, we convert that to moles and get how many molecules we have of xylene in the water tower, and that would be 1.132136 e to the 19th molecules of xylene in this water tower. Now we're going to move on to my buddy Nathan here. Nathan! Hi.
Benny Berwick. Alright, so this is our Lewis dot diagram, again for only the 15th time. So, carbon here, we have 4 valence electrons, 4 dots. Hydrogen, 1 dot, 1 valence electron. And right here we have these things called benzene rings, and because of because of the structure of the molecule, it forms benzene rings. Benzene rings are very good solvents, apparently, found out on Wikipedia. I don't know if it's true, but I'm using it. And we can use that to form good solvents, and it can form weak bonds with other things like that. Physical and chemical properties. Has a density of 0.88 grams per milliliter. Boiling point of 144 degrees Celsius. Practically insoluble in water. And its appearance is a clear liquid. Oh my, why? I hate my life. Okay, state of matter, liquid, and it is a non-polar substance. Up here is the xylene, and down here is the water. As you can see, the two do not mix because xylene is insoluble. Okay, alright, here we go. Xylene, it's, oh, why? I want to kill myself. Alright, xylene, nonpolar covalent. Hydrogen, electronegativity of 2.2. Carbon has electronegativity of 2.55. And because of this, xylene can only form strong bonds with other nonpolar substances because it is in fact nonpolar, and nonpolar substances and polar substances do not mix well. They usually sit on top of each other. Possible contamination source. This is our most likely contamination source, is all pest solutions. As you can see, it is only a couple miles from Lake Lavon itself, and it has a series of runoff rivers that flow into Lake Lavon, and therefore, yeah, because pesticides have most pesticides used by this pest control company contain xylene in there, and because of this, they run off into the river, and boop, you have contaminated water. Yummers. Not like it can kill you or anything, right? No, definitely not. Short-term exposure with high amounts. Irritation of the skin, eye, nose, and throat. Difficulty in breathing. I'm not going to read all that. You can read that. I can't English. Xylene. We have a clear, sweet-smelling liquid. It is irritating to the eye, skin, and respiratory tract. It can cause dizziness, nausea, drowsiness. We have a 230, 2 activity, fire hazard, and 0. And what should be there is eye goggles, apron, and long sleeve shirts, stuff like that. We can use it in the lab, but in very small amounts and in a very controlled environment. So, Mr. Chandler, you're going to do all the work, and we'll sit there and watch. 8-ounce glass of water. We have 8 ounces. Hoy, somebody be calling me. Alright, 8-ounce glass of water. We go from ounces to milliliters, milliliters to liters, and we have our moles to liter conversion factor. and we have 6.02 times 10 to the negative 23rd molecules. And when we do all this math, gross math stuff, we get this number right here. And that's it. That's our reference page. And goodbye, Mr. Chandler.